Watkins. So I want to general page 53, graphing simple rational functions. Example 1, identify the transformations of the graph of f of x equals 1 divided by x. That produces the graph of the given function g of x. Then select the graph of g of x by applying the transformations to the asymptotes x equals 0, y equals 0, to the reference points -1, -1, 1, 1. Also enter the domain and range of g of x using inequality, set notation, and interval notations. So g of x equals 3, parentheses 1 divided by x plus 1 equals -3. Step 1, the transformations of the graph of f of x that are produced the graph of g of x are a vertical stretch by a factor of 3, a translation of 1 unit to the left, and 3 units down. Complete the table. When f of x equals 1 divided by x, the vertical asymptotes are x equals 0, y equals 0, and the reference points are -1, -1, 1, 1. When g of x equals 3, parentheses 1 divided by x plus 1 minus 3, the vertical asymptotes x equals -1, and the horizontal asymptotes y equals -3. And the new reference points are calculated to be -2, -6, and 0, 0. All right, let's take a look at the next step. Step 3, find the domain of g of x. Domain of g of x can be found using the h value of the vertex, which means the asymptotes x equals -1. That means that your inequality is x is less than -1 or x is greater than -1. Set notation x such that x is unequal -1, and interval notation means it's from -infinity to -1 or -1 to infinity. All right, step 4, find the range of g of x. We do that by applying the k value of the vertex, which means the asymptotes y equals -3. So in inequality notation, it's y less than -3 or y greater than -3. Set notation is y such that y does not equal -3. Interval notation is -infinity to -3 or -3 to infinity. Okay, so with that, let's go ahead and graph our function. So we're going to start by graphing our asymptote x equals -1. Okay, so x equals -1. That's our vertical asymptote. And we have a horizontal asymptote at y equals -3. So all right, and so then we just need a point here and here, and we can use Desmos for that. So we're going to graph g of x. So that's 3, parentheses 1 divided by x plus 1 minus 3. Okay, so I want to try to find a point. 0, 0 works. Okay, so we can use that point, 0, 0. And then let's come down here. Oh, almost had it. Well, if you round, that'd be -4, -4. So we can use that point, -4, -4. All right. Let's go ahead and graph g of x in yellow. Okay. So I have my point 0, 0. And I have a point -1, 2. Let's see, -1, 2, 3, 4, 1, 2, 3, 4. Okay. Now, once you have the point, you realize the curve has to fall along the asymptotes in that region. So your curve looks like this and looks like this. Okay. All right, go ahead and finish up graphing. And let's take a look at the next example. Okay, example number 2. Identify the transformation of the graph of f of x equals 1 divided by x that produces the graph of the given function g of x. Then select the graph g of x by applying the transformation to the asymptotes x equals 0 and y equals 0, to the reference points -1, -1, 1, 1, also into the domain and range of g of x using inequalities, set notation, and interval notation. Okay, so we're going to go ahead and graph g of x in yellow here in a few minutes. Okay, the transformations are it's a horizontal compression by a factor of 1/2, a translation of 2 units to the left, and 3 units up. All right, and let's go ahead and, before I turn the page, let's go ahead and type that into decimal so we have it available. So 1 divided by 2, parentheses, x plus 2 plus 3. Okay, I'm going to press the home button so we have that available now, ready to go. All right, let's take a look at the next page. All right, the domain can be found by using the h value of the vertex, which is -2, which is also the asymptote. Okay. Now, the inequality notation is x is less than -2 or x is greater than -2. Set notation is x such that x does not equal -2, and interval notation is from -infinity to -2 or -2 to infinity. Now, for the range, we apply the k value from the vertex, which is 3, which is the horizontal asymptote. So we have inequality notation y less than 3 or y greater than 3. Set notation is y such that y does not equal 3. And the interval notation is -infinity to 3 or 3 to infinity. Okay, we're going to start by first graphing our asymptotes. So we have x equals -2 is our vertical asymptote. So let's graph that. And then let's graph our horizontal asymptote, which is that y equals 3. Now, once you have the asymptotes, all you need is a point in each region, and then you'll know where the curve goes. Okay, so let's use decimals to apply that. 0, 3.25, maybe we can use, but let's see if we can find a whole number point. That's probably going to be the best, -1, 3.5. So let's use that. Okay, now we need a point from this region. That looks like that's kind of a rough decimal, so we can see if we can find. Now, -4, 2.75, we can round that to a 3, so let's call that -4, 3. Okay, so we'll use that point. Okay, so -1, 1, 2, 3.5, or I'm sorry, 1, 2, 3.5 is right there. Now, since the point's there, the curve has to fall along the asymptote, so it's here. And then -4, 3. So negative. Now, I made a mistake by rounding that because that's right on the asymptote. So I need to actually keep that as -4, 2.75. Which, let's just round it to 2.8. Okay. So -4, 2.8, which is about right there, which means our curve is right here. Okay, go and finish up graphing that. All right, let's take a look at the next example. Okay, example 3. Enter the function's graph is shown. Use the form g of x equals a, parentheses, x, 1 divided by x minus h plus k. Use the graph below to find the asymptotes h and k. So the asymptotes look like it's here at 2 because the graph approaches it but doesn't touch. So that means h is 2. And it looks like we have another asymptote right here. So it looks like k is 4. So So our vertex is 2, 4, which makes sense because the vertex is the h and k value. Okay, we have our point 1, 1. Now we're going to substitute these numbers into here. Okay, so I'm going to call this x and y, and we're going to change g of x to y. Okay, so y is 1, so 1 equals a parentheses 1 divided by x, which is 1, minus h, which is 2, plus k, which is 4. Okay, all right. So now we're going to solve for a. So let's go ahead and put, I think we can use this as a basic calculator. We'll see 1 divided by 1 minus 2 is negative 1. So that equals 1 equals, that's negative 1, so that's negative 1a plus 4. Subtract 4 from both sides. Get negative 3 equals negative 1a. Divide both sides by negative 1. 3 equals a. So we plug that value and our h and k into the form. So that's g of x equals, we're going to plug into form a divided by x minus h plus k. So g of x equals, a is 3, so 3 parentheses 1 divided by x minus h, which is 2, plus k. All right, go ahead and finish up your example, start working on your assignment, and have a wonderful Wildcat day.